All right, so good afternoon again. Today we're going to look on scientific measurements. So the first thing I want to do is to define physical quantities. What is a physical quantity? List the main physical quantities
Sir,
and their base SI unit. Hear a question? All right.
sir, I wasn't hearing you for a while.
Oh, you hear me now?
Yes, sir.
Yeah, we're just starting now. All right. So we're going to explain the concepts of length, mass, volume, temperature, and time. We're going to state the SI units and instruments used to measure length, mass, volume, temperature, and time, and identify and correctly use instruments to measure the fundamental quantities. That's our aim for this week. All right, so I would like to ask you to identify the name, or no, either tell me what these are used to measure. Yeah, that would be a much better question. So what is A used to measure?
Time.
Yes,
The time.
the
The stop
time, sir.
It's
All right,
Sir,
time.
so time go here.
It's a
And,
stop watch.
all right,
Stop
that's
clock.
good. And what is
liquid.
this used to measure?
Liquid, sir. That is
Liquid.
liquid.
Liquid, sir.
All right, so I hear liquid. Anything else?
No, sir.
Chemicals.
All right, so this is used to measure volume. So this is volume. All right,
Yes, sir.
Yes, sir.
this is used to measure what?
Temperature.
Temperature.
So temperature. And D is used to measure what?
Length.
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 All right. And this is used to measure what?
Weight.
Or,
Weight.
or mass, right?
Yeah, mass.
Yeah.
Mass, sir.
All right. So not weight, but mass. This is used to measure mass, not weight. So I'll put not weight, just mass. All right.
Okay, sir.
All right. So measuring is the means by which the size, mass, or temperature of some quantity.
Good afternoon, sir.
All right. Good afternoon. All right.
That's good.
Question.
I was just asking, how do they measure time?
All right. So this will measure the time it takes to do something. So say you want to measure the time it takes for you to go to from school to Falmouth, to take a taxi from school to Falmouth. You would start the stopwatch over here. Give me a second. So when you're just leaving out, you would start the stopwatch here,
Yes, sir.
right? And as you reach Falmouth, you would press the same button, and it would tell you the time it takes to um to reach.
Okay, sir.
Okay, good. Let's move on. So
Yes, sir.
So measuring is a means by which the size, mass, or temperature of some quantity of matter or a period of time is determined using instruments marked in standard units. So basically, a standard unit is a value that can be communicated universally. So no matter where in the world you are, right, you can communicate values anywhere, right? And people will understand in other countries, in other languages, right? That's the purpose of standard units. So measurement is very important in everyday life and especially in science. It is necessary to measure so that communication about any quantity of matter is clear, right? That's the purpose of measurements. Now, measurements increase the accuracy of our observation. So let's say we um, we want to find out the distance from school to Falmouth, right? We could estimate into the town Falmouth into the town, we could estimate that, right? By saying, it's about 2 kilometers, but by measuring it, we get a much better value, and our measurements are much more accurate, right? So we could say that we could estimate and say it's about 2 kilometers. But then if we actually go ahead and measure it, right, with various systems, we can say that, oh, this is much more accurate. This seems like a much better answer. So scientists use various instruments to help them to measure things. So are we clear so far?
Yes, sir.
Yes, sir.
Sir.
Yes, sir.
Yes, sir.
Let's move on. Now we have measuring and then we have estimating. So estimating is a useful skills, but we cannot rely on these, right? We cannot fully rely, we still have to measure. So each person's ability to
Excuse
judge. I see a question?
Sir, estimating is like something like a hypothesis, sir, like you are guessing, sir.
Right. You could go ahead and make an assumption, and then you would carry out an experiment to actually test or to measure the actual size of the quantity. All right. Chat. Yes, the class is being recorded now, and of course it will be posted on Google Classroom. So, so as a result, it is necessary to use specially designed measuring equipment and standard units that give us the information consistently and globally. So, the ruler in Jamaica is the same ruler in China, or the same ruler in Germany, right? And they all know centimeters, right? Centimeters and meters, right? Everyone knows that, right? In Germany they know about centimeters. In US, right? In US,
Yes, sir.
in
Yes, sir.
Jamaica,
Yes, sir.
in Germany, everyone will know about centimeters, right? Even in China, or in, give me one more country, just one.
Korea.
All right, so even in Korea, so they know, everyone know about, everybody is using the same centimeter. So this is globally and it is consistent. It's the same meter ruler. All right. Now, physical quantity is an amount that can be measured. All right. So it's something, or it is a phenomenon, or something that can be measured. Anything that can be measured, right? We usually call them physical quantities. These are some main physical quantities that can be measured. The dimensions, which would be the size of an object in terms of length, width, and height, or even depth, right? So let's say we have a cube here. This is not the best cube. I'm sure some persons can draw a much better cube than I can. But here, what would we have here? This section here.
Sir,
Mhm.
Sir, Jaime is asking for you to please let him in the meeting.
Okay. I'm not seeing him here. Oh, okay, I'm seeing him now. All right. Right. So what
Sir,
is
that was the volume.
right? No, we're just talking about the dimensions here. So
Oh, okay.
what would be the distance from here to here?
Length.
All right. So let's say it's a width. And then
Width.
yeah. And then
Sir,
this.
Sir, I finished the work, sir, from last class.
Yes, sir.
All
The
right.
lab.
Yeah, we'll
Sir,
talk
but
about it
I'm going to
afterwards.
post
All right,
it,
that's
sir,
just
because I'm
first.
not using my phone.
All right, we'll talk about that afterwards. Okay. Now this, let's say this is our the distance from here to here,
Length.
right? That could be our length, and then the distance from here to here
Is the width.
is our height, right? Our height.
He's shouting.
Mhm. So this could be our height. So these are the various dimensions of an object, right? So these dimensions can be used to describe any particular object, say in your house or in school or whatever. All right, the next one is volume. So the volume is essentially how much space an object will occupy. All right, how much space an object will occupy. We use volume to describe this. All right, so if you find the volume of this particular cube, we will know how much space this cube takes up. All right, the next one is the mass, which is how much matter an object contains. All right, how much matter an object contains is described by mass. Time is how long an event lasts, and temperature is how long or how hot, sorry, an object is. So temperature would describe how hot an object is. I will, give me a second here. Let me fix something quickly. Let me just go ahead and fix something here.
Sir, you stop sharing your screen.
Yeah, give me a second. Let me fix something. All right, let me go back and share again. You were here.
Yes, sir,
Right.
I'm seeing your screen.
Okay, good.
See this.
All right, so as you said, the temperature is how hot an object is. Now, we have seen this before just a while ago, and we spoke about what these measure. Now we'll go ahead and name them. All right, we'll go ahead and name these.
Yes.
So what is this again? What's the name of this?
Timer.
All right, a
Timer.
timer, stopwatch, right?
Yes, sir.
Yes, sir.
Stopwatch,
Yes, sir.
Like the one we have on our phones.
right? Stopwatch, exactly. And this is a what? You will know what this is?
Cube. No, no.
All right, so this would be a measuring cylinder.
Yes, sir.
Measuring cylinder.
Measuring cylinder. I hope it can hold here. I'll put it on here. Cylinder. And this is what?
Thermometer. Thermometer.
So
Thermometer.
thermometer. Right? And what is this?
Sir, wait.
A
The ruler.
All right, so a meter ruler.
Yes, a meter ruler. Yeah, meter.
Right? And the last one, remember this from last class?
Sir, I don't remember the name of it.
A scale.
All right, so some might say scale, but the scientific name for it is a balance. So we usually say
Okay, sir.
Balance.
top
Bal
pan balance.
top.
All right.
Yes, sir.
All right, so we all clear on this now?
Yes, sir. Yes, sir.
Okay. All right, so let's go to standard units now. We say standard units are used so that we can make useful comparisons in science. We mostly use standard units. In science, we mostly use standard units. Standard units mean international system of units of measurement. So as you said earlier, it can be used anywhere in the world, right? And we have some here. We have the physical quantity of length, and the standard unit is meter. All right, the symbol is meter for meter, M, and the instrument is meter rule, tape measure, or caliper. All right. I will try to adjust these so that you can see them much better next time, or when I'm uploading the notes, I'll try and adjust them. All right. So the next physical quantity is your mass, and it is essentially measured in kilogram. Right. The symbol for kilogram, right?
kg.
Kg, right? And to find the mass, we said we use a balance. All right.
Yes,
So
Yes,
sir.
sir.
once
Yes,
we say
sir.
balance, we know that it has to do with mass. The next one is a time. Is time a physical quantity? Is time. The SI unit is
Second.
right,
Second.
and the symbol is S.
S.
Yes, sir.
So we usually use a clock or a stopwatch, as we saw earlier.
Stop.
Right. The next one is temperature. Temperature, and it is measured in Kelvin.
Kelvin.
Right.
Yes,
So
sir.
we might see degrees Celsius, but in science we measure in Kelvin, and we'll talk about that. We'll talk about that more in the future. But in real life, like in your everyday life, you might measure in degrees Celsius, but in science, we convert degrees Celsius to Kelvin for important calculations. All right, and we'll talk about
Yes,
why
sir.
in the future.
Yes, sir.
All right,
Yes,
so
sir.
the symbol for Kelvin is K,
K.
and the instrument is our, of course,
Thermometer.
right? And we said that the physical quantity for volume, right?
Volume.
This SI unit is liter,
Liter. Liter.
the symbol is L,
L.
and we said that the instrument we use is the measuring cylinder.
Measuring cylinder.
All right, so as the same thing over here, right? They are essentially the same thing. So this is what a measuring cylinder looks like, and it is used to measure volume. All right, so are we all clear so far?
Yes,
Yes,
sir.
sir.
Yes,
Anyone
sir.
not clear?
Yes,
Anyone
sir.
that is not clear?
No, sir.
Sir Ariel.
All right.
Sir Ariel.
Ariel is not clear?
Yes, sir. She doesn't understand the last part.
All right, which last part does she not understand? The one over
At the
here?
end. Yes, sir.
Where exactly? The temperature?
Yes, sir.
All right, so the physical quantity is temperature. Let's go over it again. The SI unit for temperature is in Kelvin,
Kelvin.
right? Remember that it's in Kelvin. We use degrees Celsius in our everyday life, right? But essentially, when
Yes.
in science we use Kelvin, and the symbol for Kelvin is K,
K.
and the
Sir.
instrument is our thermometer. Question?
Sir, how did it get that name, sir?
Right. So the person who actually came up with the concept of it was from gas laws. All right, so I'll just talk about it briefly. So this particular person, his name was Kelvin, and he realized that at a particular temperature, right, which is negative 273 degrees Celsius, right, there
Yes,
is
sir.
everything stops moving. So all matter stops moving at this particular temperature.
Yes, sir.
So he was the one that came up with this. So therefore, 1 Kelvin, right, at 0 Kelvin, this is this negative 273 degrees Celsius is equal to 0 Kelvin. All right.
Yes,
So
Okay, sir.
all right. So this person came up with that particular, and he tested it, and he saw that it was true that all matter stops moving at this particular temperature. All right.
yes, sir.
Okay, sir.
Yes, sir.
It's
Yeah.
0 degrees.
That's zero. That would be 0 Kelvin. 0 Kelvin is equal to negative 273. We'll talk about it more in a few slides down. All right.
Yes, sir.
Yes, sir. Yes, sir.
All right. So other units are used, such as degrees Celsius for temperature, grams for mass, and minutes for time. Right. So note that 1 kilometer is equal to how much meters?
Per feet.
All right. 1 kilometer is equal to
1,000 meters.
right. So 1 kilometers is equal to 1,000 meters, and 1 centimeter, right? So therefore, this will be
1 meter.
so that means that 100 centimeter, 100 centimeter is equal to what?
1 meter.
1 meter, and this would suggest that 1,000 millimeter is equal to what? 1 meter. So centimeters are often used for area and volume of everyday objects, but we should convert these into meters in scientific calculation. So in calculation, you should convert. All right.
Yes, sir.
All right.
Yes,
So
sir.
Yes,
the
Yes, sir.
physical quantity, we have area and volume. Have you done this in maths? You done area and maths?
Yes,
Yes,
sir.
Sir.
All
Sir.
right. What is the area of a square? If you have a area, so it would be length times width.
Times
With
weight.
All right. That's good. So the volume of a liquid is often measured in
Sir, it would
liters.
be by which, sir? Sir, it would be side by side.
Go again?
Sir, it would be side times side. Because all of the sides are equal, sir.
Yeah, essentially.
Yes.
but it's still length times
It would still be A times A.
Side by
It would still be the same thing. All right? Because both
Yes,
sides
sir.
are
Yes,
equal.
sir.
All right? And are you familiar with volume?
no.
Yes.
No, sir,
no,
I
not really.
remember. I remember learning it,
A little bit.
but
All right. So this is area. Area here. Now for volume, you should have cubic centimeters. So to find the volume of this cube, right? Let me try it bigger.
Sir, did you say something, sir?
Give me a second. Alright. I'm sure there are some persons who can draw a much better cube than this, right?
Sir,
Yes,
you can
sir.
draw.
Sir, I can draw it as well.
All
Sir,
right,
I
so
can draw too, sir.
all right, so we want to find the volume. So volume of this would be length times width times height,
With and height.
right? So this is the volume of a cube.
Yes, sir.
Yes,
Alright.
sir.
Length times height. And the area of a square is just length times width or times A. All right.
Yes, sir.
Yes, sir.
So the volume
Yes,
of a liquid is often measured in liters and milliliters. So 1 milliliters is equal to 1
One
cubic meter. So this is equal to 1 centimeter cubes.
Yeah, 1 cubic.
All right. So 1 milliliter is equal to 1 cubic centimeter. All right. So is this clear?
Yes, sir.
Yes, sir.
All right, so this is a lot. Today we have a lot to cover. All right,
Yes,
so
sir.
let's convert from meters to centimeters. All right, so how much you say 100 centimeters is how much again?
Sir,
1 meter, right?
Yes, sir.
yes, sir. Yes, sir.
100 centimeters is equal to 1 meter. So say we measured the length as 200 centimeters. 200 centimeters, right? We would put 200 down here below the centimeter, and then we want to find it in meters, so we place X here.
2 meter.
Right, it would be 2 meters. But let's just go through it. The next step would be to cross multiply. So what would we have over this side? We would have 100 times X, right?
Yes, sir.
And then this would be 200 times 1, right?
Yes, sir.
Yes, sir.
Now, to find this particular value, we would divide both sides by 100, right?
Yes.
sir.
That by 100, you would have 100 over here, 100 over here, and we would divide both sides. So these would cancel, leaving us with X equal 200 over 100. Now, what is the final value of this? X is equal to how much?
200.
200 divided by 100 is how much?
Sir,
So 2
sir,
meters, right?
Yes,
Yes,
sir.
sir.
Is that
Yes,
clear?
Yes, sir.
All right, anyone doesn't understand?
No, sir. No,
sir, can we just go over the mass part of it, sir? Like just the
sir.
first part of it, sir.
I came in late. My in was helping.
All right,
Yes.
let me go over it again.
Can we go over? Yes, sir.
Yes, sir.
All right, so we have a
Yes,
length
sir.
of 200 centimeters, right? That's what we want to convert this to meters. We want to convert 200
Actually,
centimeters into meters. So we know I'll go ahead and mark on. Okay. So 100 centimeters is equal to how much?
1 meter.
Sir, 100 centimeters is
Right.
equal to
So
1
therefore,
meter.
we would place 200 under the centimeter section. This is the centimeter section and this is the meter section. Right? So therefore, we would divide both sides, right? We multiply, we cross multiply. So therefore, we end up with 100 times x, then 200 times 1, right? This will leave us with 100x
Yes, sir.
equal 200. If we divide both sides by 100, we would end up with just x over this side, and then we would have 200 over 100 over this side. All right.
Yes,
Yes,
sir.
sir.
Then the final step would be to divide 200 by 100, and we eventually get 2 meters. All right.
Yes, sir.
Yes, sir.
Sir.
All right. So the next one is meters to kilometers. So how much meters make 1 kilometer again?
Sir, sir.
100.
Right. We said 1,000.
Yes, sir.
Right. 1,000 meters make 1 kilometer. Right.
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, I think so that be wrong.
So 1,000 meter
Makes 1 kilometer.
is equal to 1
To
meter.
1.
And we want, let's say we want to convert 300 meters to kilometers, right? No,
Yes,
which
sir.
side would we place the 300? Over this side or over this side? Wait, give me a second. Let me fix something. There's a mistake here. Right, working. 1,000 meter is equal to 1 kilometer. So where would you put the 300 meters?
Sir, on the other side.
Over this side or this side? This side or this side?
Over the 1,000 side.
Over the 1,000 side, right? Because it's under the meter section.
Yes,
sir.
So it will be 300 meters equal to x, right? This is what we want to find. Therefore, we would multiply both sides. We cross multiply. So we would have 1,000x, right?
Yes, sir.
Yes, sir.
Yes, sir.
Equal to, what would this be equal to?
3.
300 meters.
So 300, right?
yes,
Yes,
sir.
Yes,
Then
sir.
what would the next step be?
Put them over a
Right.
1,000.
Yeah, so put both sides over 1,000 and put both sides over 1,000. You could divide both sides, right?
Yes, sir.
So you
Yes,
cross this out and you cross this out.
Put
And
1.
so you'll be left with x
And
equal
then x would
300,
equal 300 over 1,000.
right?
And x would be equal 3.
What would be this? You have a calculator?
No,
Yes,
sir.
sir. I have my calculator.
All right, what would this be equal to? 300 over 1,000?
Sir, time
3
Divided by
kilometers.
Will be
sir, 0. Sir, the answer is, it says 0.3
right. So this is 0.3
kilometer.
kilometers. So is it clear?
Yes, sir.
Yes, sir.
All right, so the last one is very easy. So we go with degrees Celsius to Kelvin. So 1 Kelvin is equal to degrees Celsius plus 273. So 1 Kelvin is equal to degrees Celsius, the degree Celsius plus 273. So suppose we had 25 degrees Celsius. This would be equal to 25 plus what?
Sir, can you repeat? I didn't hear.
273. Now what would this be in Kelvin there? 25 plus 273.
25 plus 273.
Sir, 298.
All right,
248.
298. 298
Sir, I got 40.
Kelvin, right?
Yes, sir.
Yes, sir.
Someone got something different?
No,
Sir,
sir.
I got 248.
298, sir.
You have to add them. So you have to add 25
Excuse
plus
me, sir. Sir,
273.
sir, someone was
Question?
talking, sir.
Oh, sir, I thought you said 223, sir.
No, 273. All right. All right, let's try one more exercise.
Yes, sir.
Let's say we have 32 degrees Celsius. Let's say that's what we have. Right? Now, 1 Kelvin is equal to degrees Celsius plus what? 273. So therefore, what would you put here?
32.
32 plus
32 plus 273
right.
equals 305.
Sir, 305.
All right. So 32 plus 273 is equal to 305 what?
105 K.
Kelvin, right?
Yes.
Yes,
Yes,
sir.
sir.
All right. So is it clear?
Yes, sir.
All right. All right. So the last section that we have is to look on meniscus. You know, whenever we're reading values, we want to measure. We want to do that at eye level, right? So we see the eye here. We would read at the bottom of the meniscus. So whenever we're reading, you are measuring cylinder, you will find out that there's a curve. And you'll see that whenever we're doing exercises, let's say we go back face to face, I will show you that there's a curve here. No, the right way to do it is by reading at the bottom of that curve.
Yes,
And
sir.
not at the top.
Yes, sir.
This is wrong. So don't read at the top, you should read at the bottom. All right? So
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
what would this reading be? Let me just fix that.
Sir, repeat.
50.
All right, so this would be, what would this be?
50.
Right. And say this is in milliliters.
50
So 50
milliliter.
milliliters.
milliliter.
Right. Now, this is saying that this is poor, right? This is low reading. If you're reading from this angle, right? And then for this angle, you get an incorrect reading as well. Where should you read it?
In the center.
Right, at the correct line, right?
Yes, sir.
Yes,
In
sir.
a correct line of volume.
Right. So this is the correct line of volume. right in the center. Don't read at an angle. All right. So you'll go ahead and read these. Now, what is the reading for this?
89.
All right. So this is 80,
Yes, sir.
90, right?
Yes,
What's in the
sir.
middle here?
84.
80.
84.
So this is 85,
85.
right?
Right.
What would 85 be?
85.
84.
84, sir, because the line is not all the way at 85.
Exactly. So there's a you have 80 here, and you have 90 here, and you have 85 in the middle. But then
Yes, sir.
this is not exactly at 85. So this would be at 84.
Okay,
All
sir.
right. Now, what is this value?
700.
Exactly. So this would be 700, right?
Yes, sir.
Yes, sir.
And this final
Yes,
one, let's
sir.
look at the time now. What time is this?
15 minutes to 4.
15 minutes to
All right. So what would this be? Let's say, let's put it the other way.
15 minutes past 4.
No, let's put it the other way, right? In terms of like 12.
40. Yes, sir. Can
Alright,
you
so
tell
I
Akira
hear-
to stop shouting?
So I hear 3:45. Is that the case? Is that correct?
yes. Yes, sir.
Yes,
Yes,
sir.
sir.
Akila, can you
Just
please stop
all the way
shouting?
at 4, sir. And then 9, sir, you would count it from 5, sir.
All right. So this is 3:45 or 15 minutes to 4.
Yes, sir.
All right. So that's it for today. All right. We have 2 minutes to spare.
Okay, sir.
Okay,
Sir,
sir.
can you tell Akila to stop shouting?
She said to
Please.
stop. You there?
All right. Akila. All right. Try your best not to shout. Okay.
Sir.
Oh, she stutters.
Okay. All right. Let's try and work. I know this is difficult, right? But let's try our best to work with each other. All right. So, all the best, everyone. I'll
Yes, sir.
upload the,
Same to you.
Same to you,
Same to
sir.
you, sir.
To you, sir.
I'll
Same
upload
to
the
you, sir.
Google Classroom. All right.
Okay, sir. Sir, should we write off the notes?
No, the notes will be posted on Google Classroom. You don't have to write it off. If you want, you can. All right, but you don't
Try
have to.
to screenshot, sir, to remember them.
Okay. All right, the notes will be posted on Google Classroom.
Yes, sir.
Okay,
When I'm
sir.
studying,
Okay,
Okay.